Hello and welcome to our webinar. My name is Amarnath. I'm software architect with Palladium Networks and I primarily deal with security assessment tools. Today we'll discuss growing issues of cyber attacks which has led to revenue loss and even business discontinuity. We'll discuss some of the prevention techniques and also the automation possibilities of such prevention techniques. With this backdrop, let me start the webinar. Industrial sectors have enjoyed the boom in e-commerce with the exponential growth in use of web and mobile technologies, whereas security considerations still remain an unattended area. Security upscaling has not been at par with the rapid pace of growth. This trend has given rise to cybercrime as they seek for more and more monetizing opportunity. Year 2014 has witnessed 48% rise in information security incidents. That's a huge number and that's a huge security incident ratio to address too. IT sector has been badly hit in 2014. In June of 2014, Evernote, which is a popular note-taking app which we use in our day-to-day life, was unavailable to its million users due to a DOS attack. When I say DOS, I mean a denial of service attack. The site was unavailable for several hours by slamming it with traffic from a variety of sources. Similarly, on 19th of December, retail giant Target Systems had came across a massive cyber attack that resulted into leak of millions of credit and debit card accounts. Now, there are complicated ways to do an attack, but surprisingly, most of the attacks are carried out by exploiting configuration loopholes. The reason is that configuration loopholes are easy to overlook and they compromise on utility, so there is always a tug of war between the utility and security aperture. Similarly, DOS attacks are possible by exploiting configuration loopholes of a system. For example, there are certain configurations in TCP/IP protocol of an operating system which can be exploited to conduct a successful DOS attack. If we analyze the attack on Target Corporation, the hackers have used footholds to crawl through the network until they gain access to the cash register system. They have actively scanned the system for remote access opportunities and thereby deploying computers to guess the username and passwords at a very high speed until unless they have hit the right combination. In 2014, if we analyze the attacks or the cyber attacks of 2014, we can easily observe that misconfigurations were the #1 vulnerability. The biggest threat to most of companies' cybersecurity was actually server misconfigurations, which allowed unauthorized access to data and opened up further opportunities for vulnerabilities or attacks. And this report was highlighted by Verizon's data breach report of 2014, wherein they have published the distribution of attacks by various types and various controls. And one can very clearly observe that the boundary controls and the secure configurations were the top critical controls. Now, while the primary approach will be to harden the systems by proper configuration, but that is not enough, as the primary challenge with configurations is that they are dynamic in nature and meant to change as per the need. Hence, it is required to continuously monitor the changes of configurations and critical assets to prevent these kind of attacks. Let's move on and let's have a more detailed look into how these attacks are being carried out and what can we do to prevent them. Let's look at the DOS or the DDoS attack, for example. It stands for denial of service, which simply means you have a service offering to your customers and the service has been denied to being offered to the legitimate customers, and the bandwidth is choked by the random or the non-legitimate users. It is a network-based attack. The modus operandi is to create legitimate network connections and keep it open so that your bandwidth is choked. Servers get overloaded and you cannot serve your actual audience. Another modus operandi for this attack is to obstruct the communication media between the intended users and the victims. Now, the impact is drastic. You can lose your customer interest, and as your servers are loaded, they cannot serve the genuine customers, and hence they lose interest in your online services, and it would incur a direct revenue loss. There are four most commonly used ways in which this attack has been done so far, as when we have analyzed the security understanding of these attacks. So we can broadly classify these attacks into four types. One is the volumetric attacks, and these attacks are simply about causing congestion by attempting to consume the bandwidth within the target network. Then TCP-based attacks. These attacks attempt to use all the available connections of the underlying infrastructure. Then we have fragmentation-based attacks. These send a flood of TCP and UDP fragments to a victim, overwhelming the victim's ability to reassemble the streams and severely reducing the performance. So basically, we know that when the TCP/IP communication happens, it happens in fragments. The message is broken down into fragments and sent across in bits and pieces. So it takes server time or the processor's ability to, first of all, break down a message into fragments, and in the similar way, the fragments have to be reconstructed on the target side. Now, if you deliberately keep on sending fragments which cannot be reconstructed, your target machine will keep on processing those miscrafted fragments and try to reconstruct the data, whereas it is not possible. But it will, at the end of the day, it will slow down the server's capability to process your genuine customers. And the fourth type of attack is an application-based attack. These attempts to overwhelm a specific aspect of an application or a service, thereby leveraging the congestion in the traffic and hence doing the attack. That's more or less how broadly we can classify the denial of service or DDoS attacks. Let's look at data theft. Now, data theft is conducted mostly to steal critical information like credit card details, personal information, etc. Most of the time, the weak user account configurations are exploited to get access to unauthorized sections of critical data. Now, the impact of this kind of attack is very high. You can face a legal lawsuit. You can have a revenue loss, direct revenue loss, because at the end of the day, the financial data or the monetary aspects of your data have been lost. And you can face a business discontinuity as such. I would like to recall an attack happened on a company called as CodeSpace. Hackers have taken access to the core data center zone or the area where most of the data of the customers were preserving, as well as they had taken the access to the backup sites of the core data. Well, the attackers, maybe the intent may be anything, they have asked for a ransom note and they they have asked for a ransom amount. And the company, they have not taken the matter seriously and have avoided that particular incident. The attackers, they got irritated by that and they have deleted all the core data, including the backup data. The company was not able to recover from such data loss and was shut down within just 12 hours of this attack. That is the level of damage which can happen if a company is attacked by data theft, or if the intent of the attack is data theft. Now, this attack again can be broadly classified into two types. Actually, this attack has a lot of flavors and varieties, but due to the timing constraints and limitations, we would like to limit ourselves to two major categories. One is the brute force attack, and another is the man in the middle attack, wherein a person tries to sniff out the data. Now as we have discussed the attacks and how they have been done and what would be the impact of all such attacks, let us discuss how do we prevent such attack, and more specifically, what is the role of secure configuration in prevention of these attacks. Well, before we go further, let's take a moment to understand the demo setup, or a virtual setup. It's a fictitious setup wherein we can assume we have a web server which is running an enterprise grade application, maybe a customer portal or an internet site. And to run a web application, you need an underlying operating system. On top of it, you need a web server. This web server will actually process the requests of the application and serve it to the legitimate customers. On top of it, generally the enterprise grade applications will also have a backend. So assume we have a backend server running in Microsoft SQL Server 2008, and which is again running on top of a Windows 2008 R2 server. So assume this is our infrastructure setup, and on this infrastructure some sort of corporate portal or internet website is running, which is actually serving your audience with the data or the services. That being said, let's see how each of the attacks can happen and what you can do to prevent it. If you can see the DOS attacks or denial of service attacks, one of the ways is to exploit the TCP/IP stack settings of the attack to do it. Now, TCP connection and fragmentation attacks are done by exploiting the TCP/IP stack settings. In Windows 2008, there are some important configuration parameters of TCP/IP which has to be hardened to prevent these attacks. Now, as you can see over the screen, some of these TCP/IP stack settings are enable ICMP redirect, SYN attack protect, keep alive settings, max connect response retransmissions, and TCP max data retransmissions. Now, to clearly explain how it can be exploited and an attack, how it can happen, assume your UI engine of the web server from the fictitious corporate portal which is running. Huge traffic comes in, and since your internet portal or the corporate portal is served over an HTTP protocol, which is by default relying on the TCP/IP protocol, if somehow the TCP/IP protocol can be congested and the bandwidth can be choked, your actual service offering to your legitimate customers will get choked. Now, if you see these parameters, the SYN attack protect, this is a registry key, by the way, and this value causes the transmission control protocol to adjust the retransmission of synchronous acknowledgements. If you configure this value correctly and the connection response timeouts are more quickly in the event of an synchronization attack. So you need to adjust this value properly so that during a retransmission this attack is not, it's very less likely to happen. In the same way, if you see the keep alive time, this value controls how often TCP attempts to verify that an idle connection is still intact by sending a keep alive packet. So again, adjusting this value will again reduce the likelihood of exploitation of a DOS attack. Now there are some other parameters like TCP max connect response retransmissions and TCP max data retransmissions. These parameters, they are used to define an upper limit or upper threshold of the attack, and if you set them properly, it helps you to reduce the chances of the exploitation. In the same way, there are some application and volumetric attacks which can be done on the UI server or the web server where your Windows, which is serving the internet traffic. Now, if you have a remote desktop session, or if you allow remote desktop to be taken to your server, the session time limit settings has to be adjusted so that the application is not choked, so that in case of any legitimate requirement, somebody can log into the application and take a backup or do certain maintenance activities. And then on the IIS server, which is actually processing the web request and sending the pages out, there are a couple of important settings which has to be done, like number of concurrent requests, the HTTP connection timeout, max query string property. These are certain underlying properties of IIS and Windows which has to be adjusted so that the DOS attacks can be, the likelihood of DOS attacks can be minimized. Apart from it, there is another angle or another facet by which this DOS attacks can be conducted. Well, it's not directly linked, but it's also possible by exploiting the non-essential services running and exposed over network. Now, it's a different category of prevention altogether, but the thought process is that if you don't need a particular feature to be running, then why to keep it running? As you are not actively using a particular feature, it may remain unpatched and hence it can be exploited. For example, in the UI engine, all the .NET service related or ASP.NET services, the IS admin services, the worldwide publishing services are supposed to run because it is actually serving the traffic. But you don't need these services to be running on your backend engine. So why to keep it running over there? Why not shut it down? So this is more of a preventive technique. This kind of thought process doesn't involve what exactly is the attack. The thought process is simply if you don't need something to be running, just shut it down. And this is not a general practice. This is even mandated by top compliances like PCI DSS and ISO, which clearly mandates removal of unnecessary functions and services. Now, coming to the data theft attack, again, one has to legitimately think that where the data theft can happen. Most likely, a data theft attack will be attempted on your database server. It may not, or it may occur on your web server, but the likelihood is very less because the critical data or the critical information is actually stored in your backend. It's not stored in your front end. So if somebody has to steal the important information like credit card or the identity information, they will actually try to do it on your backend. They can exploit the weak password complexity. Assume you have not set a proper password complexity, you have not set an account lockout system in place. Then somebody can deploy a high-speed guessing mechanism by which they can try to guess the username and password, and if they get the combination right, that's it, that's the end of the story. Once they get the credentials, they can literally perform all sort of activities, including a DOS attack as well. Now, in the equation of username and password, there are two variables. One is the username and another is the password. Now, if you use the default username like administrator and guest, half of the equation is already solved. Then the only thing which is pending is to guess the password. But if you do not use the default usernames, you still make the equation complicated because the hackers don't know what is the username. Forget about the password altogether. Then guest access to database. These are certain configurations which, if are applied to your servers, definitely can be exploited to get an unauthorized access. Now, this is one of the scenarios in which the brute force attack can be done on your database server. Now, let's discuss the man-in-the-middle attack or the data theft using the MITM kind of scenario. Now, this kind of attack is about sniffing out data over the network. You know, it really doesn't hacks or cracks down into the server and tries to steal some valuable information. What they do is they try to sniff the data over network. They try to position themselves between the network and any data which is unencrypted going out from the target server to the actual audience. They just reconstruct the messages and try to steal the data. It can happen if you don't have any encryption set for your RPC communications, then the SQL client server traffic is not encrypted. There are a lot of ways in which a particular attack can position between yourself and the actual audience. Whereas the audience will not even know that the data is routed via an intermediary server, and the server will also never come to know that the data is routed by some server intermediary, and hence the complete data transmission, if it's not encrypted, it would be stolen just like that. Now, how this MITM attacks are being conducted involves a lot of craftiness into this area. One of the ways is DNS poisoning, by which I change your DNS records in such a way that rather than connecting directly to the server, it actually goes to intermediate server and which routes the packet back to your original server. This discussion is out of scope, and since we have limited time constraints over here. Now let's discuss how do we do such configurations and how do we manage such configurations. Now, we have discussed the attacks and their prevention techniques, but the biggest question is how to do it. One can manually log into the system and find out improper configurations. However, it requires technical acumen to conduct a configuration scan. There are diverse systems available, with each having a different way of reading and setting configurations. It requires multiple subject matter expertise to carry out the task if you have a wide variety of systems. As long as you are dealing with probably 2-3 nodes, this is not a problem, or it may not be an apparent problem. But consider 500 plus servers to be done. The magnitude of effort is just beyond justifiable. So Palladium has a software solution for doing the configuration scan. It's called as RiskView-SCM, and we will use this for demonstration because manually conducting is a lot of time-taking activity, and also we don't recommend it because there are human errors involved in between. So before we use the tool for demonstrating how to do it, let me just quickly take 2 minutes to introduce the tool. It's called as RiskView-SCM. SCM stands for Security Configuration Management. It is a web-based system for performing configuration audits. Just to get the nomenclature out of the way, the technical compliance checking, hardening, configuration audit, they are all the same thing. It's just known by different names, or there may be some slight changes over there. It can audit most commonly available operating systems like AIX, HP, Unix, Linux, and Solaris. It can audit database servers like Oracle and SQL Server. web servers like IIS and Apache, devices like Cisco. So it can pretty much cover most commonly used systems, and a lot more supported platforms are on the way. Uh, let's have an architectural overview. So you have a controller, the Rescue SCM, the core is a controller server which connects to a configuration scanner, and the configuration scanner actually connects to the target systems and do the configuration audits or technical compliance checking or policy automation. Additionally, this controller can also talk to a network scanner or an application server to detect the vulnerability. So currently the tool is integrated with vulnerability scanners like Nessus and OpenWAS so that it can perform a network-based scan as well. The data which has been pulled out as a result of configuration audit or network scan has been accumulated in the database server, as you can see. And this database server serves as the central repository for the complete vulnerability information. And a UI engine is exposed via a web server, which is given to the end users for them to operate the tool in an easy way. Now, here is what we are going to do. We are going to define the policies. We are going to create profiles around the policies. Then we'll scan the assets. We'll analyze the findings. We'll see how to remediate them. And then again, we'll rescan the assets to see whether the remediations have been done properly or not. Now, let us define the policies. Now, what is a policy? Policy is nothing but what you want to check. Then the set of policies, they are grouped together, and that is called as a policy profile. Now, policies in Rescue SCM are created using something called as a security programming language. It's a very simple language. It's basically a scripting language. It is very easy to learn and use, and it's nothing but more of a data collection APIs which are being created by or which are being exposed by the Rescue SCM engine, and they are being used by the scripting language for collection of various data. So essentially, the core engine exposes the data collection APIs which can be used to extract data from the target machine. And once you have the data, you can write your analysis logic to check for the safe conditions. Let us look at a simple policy. The script which I am showing in the screen is a sample policy which defines a particular registry path. Then it calls an API function called as get HKey local machine registry key. And what I'm trying to do is I'm trying to get this So we are live again. Sorry for the delay. Yeah, we are live again, and I'm sorry for the delay. We just lost you temporarily, but nothing to worry. Yeah, so what I was saying is that we have the one which appears on the screen is a sample policy, wherein I am giving a registry path and I'm trying to get the data for the SYN attack protect TCP/IP stack parameter which we have just discussed. And then what I'm trying to do is I'm trying to see whether the value of this SYN attack protect is 1 or not, because a reg word of 1 is actually says that the value setting is correct. And then if it is 1, I'm generating an output that my TCP/IP settings are safe. If it is not 1, I'm generating an output that my TCP/IP settings are unsafe. So let me do a live demo to explain this thing much more properly. So what you can see on the screen is the RISC-USCM. And let me go to the policies. And yeah, so what you can see on screen is basically the various values, and the same script which I have written or I have shown in the PowerPoint presentation. I just take this value over here and I've just written the script, and now this script has to be tested. So you can select a target asset. So I'm just selecting a target asset and I'm just saying run, and the script is under execution. So it does. So what it does is basically this get HKey local machine is a API which will collect the data of the SYN attack protect keyword from the path which we have defined for them, and it will fetch the data and it will analyze what is the output, and if the output is fine, it dumps the thing. So fine, the execution is over and it is saying the TCP/IP settings are safe, and this is how the policies are written in RISC-USCM. I think the audience is getting a bit of network glitch, but yeah, but I think now we are all set. Okay, so moving on. Now we have seen how we define the policies. Now we would now go ahead and create the profiles. So now what is a profile? Depending upon the role or function of system policies selected, a profile will be created. Now profiles are grouped together for reuse, because once I understand that this particular server is used for performing certain functions and features, based on that particular functions and features, I would create a particular profile, and I will group those policies under one profile which are applicable for a particular affinity of servers. So what I'm trying to say is the TCP/IP settings, session time limit settings, and the web processing being disabled, these are my three key policy profiles which I would like to group under one policy profile, which I will use for backend server, which is just doing the database interaction. Whereas the TCP/IP stack settings and the session time limit settings, I will group this profile, I group these policies under a web server profiles, and I will run it I will run it against the web server, because these are the primary things which I would like to just see. Now let us see that how does it happens. As you can see on the screen, these are the various profiles which RISC-USCM has. As you can see on my screen, these are various platforms and various devices, and operating systems which RISC-V supports. Now, if I go inside the Windows 2008, I can see there are a lot of repositories and policies and profiles which are there. Now, RISC-V has a huge repository of predefined policies which can be used to assess the insecure configurations in any target machine. We can search by keyword over here. For example, I just want to search for what all things are available for a TCP/IP setting. So I would say TCP, and I would search in the name, and let's see. And there is one setting called as TCP/IP stack settings is weak, and that particular setting, if I go inside that policy, I can see what is the description, what is the scenario, what all parameters have to be checked, and what are their default values and formats, as you can see on the screen. This repository comes inbuilt with RISC-V, and you can use this repository to directly assess the configurations. Now, if you can see, we have various policy profiles. As you have seen in the repository, there were a lot of policies which are defined against various platforms. You may or you may not need multiple such policies at once. So what we do is we create profile. So let me create a sample profile and demonstrate. So let me say I'm saying I have creating a demo profile. Select a asset group, let's say Windows 2008, and I'll create the policy profile. Now in this profile, I'll just create a node because that is how we are going to segregate the policies, and I'll say basic checks. Now in this policy profile, we have created a hierarchy, and inside the hierarchy, let us go and add some policies. Now, a lot of policies are here. You can simply go ahead and enable or disable any policy over here, and once you enable or disable all the policies, it gets enabled under that node. And if you go back and you see that these three policies are enabled under this particular hierarchy. So basically, if you have a huge repository, you can do all sort of permutation and combination to select various policies as and when required. So for today's demonstration, I have already created three profiles. One is a Windows profile for DOS attacks of Windows 2008, where I have selected three policies like web processing, TCP/IP stack setting, and session time limit settings. In the same way, I have created some other profiles. One is for SQL 2008, which is having two broad categories. One is the network security setting, and one is the account security setting. After I define all these policies, the next step will be to scan the assets. Now, here is what is a scan lifecycle is. We select an asset. An asset is nothing but an information processing node. It can be an operating system, database, or a device. We select a profile. A profile is basically a set of various policies which can be used to check in the asset. Then we scan the asset. Once the asset is scanned, we analyze the findings. Now, what happens behind the screen is the policies are written using the security programming language. Those small snippets are ran against a target node. The data is collected, and as per the logic which you have written, the analysis has been performed. Sometimes things may go wrong. Sometimes the data is not collected. Sometimes you have network connectivity problems. So after you see the responses which have been gathered for various scans, you analyze and try to see whether they're proper or not. And if it is not proper, you can just rescan it again. Then we prepare for finishing the scan. Basically, what I meant by preparation is sometimes when the data collection is not there, you might have to manually intervene to adjust some of the findings. Well, it's an advanced topic, but we can discuss it in some other demonstration. And finally, we finish the scan. Once you finish the scan, all the responses which you have gathered, they have been converted to compliance and non-compliance. So let us see how does this particular life cycle works. I'll click on scan, and then in scan I would say create a scan. Now I know this particular asset is of type an operating system and is of type Windows 2008, and you can actually search for such as that I can select it easily. So here is the asset BFMS backend OS and BFMS OS, and let me just scan this asset to see what is this current status. So I take this thing and I can directly initiate a scan, or I can create an audit and adjust the policy. Now the policy selected is something else, so I will select the right policy and I will say start scan. Scanning has been started, and the periodic updates will keep on coming as and when the scan happens. You can also go in details and see that what exactly is going on. So as you can see, the first check has been done and it has appeared as non-compliance. So you can click on this observation and you can see what exactly was the observation by which it is shown as non-compliance. So ASP.NET state services are manual, IaaS admin services are manual, worldwide publishing services set as auto, and that is the reason why it is being shown as non-compliance. Now let others can go through. It takes about some 2-3 minutes to finish, so just bear with us. So let me show you some finished scan because it will take some time and we are running out of time here. As you can see on the screen, I have done some of the previous scan, and this is how the scan looks like. You can go inside it, and basically it is showing a summary of how many were compliance, how many were non-compliance, and what was the compliance level. You can download your various reports, the finding report, summary report, and detailed report. We support all type of formats like Excel and PDF. So let me download a report and see how does it looks like. Now this is the audit report, and you can see that the checks which has been ran against the server, and you can see what was the description, what was the impact, what was the observation, and what is the solution for this particular issue to be fixed. Now this solution is coming from our knowledge repository itself. So the Rescue SCM tool is very well equipped with all the solutions which has to be carried out for remediating a particular issue. Let us go back to our scan and let's see what is the status. Okay, so the scan is completed now. As you can see, the scan is successfully completed. So let us see the details. What we can see is basically the NS4, as in the TCP/IP stack settings, are weak, and we can click on observation, and it can tell you that which all particular values have been detected and what all things have not been detected, and what was the current setting, why it was shown as non-compliance, as this complete thing comes into observation. Moving on, after the scan has been finished, the next step is to generate the findings. So what do I mean by generating the findings? Basically, as you can see on my screen, first the responses are collected for all the policies. So first we run all the policies and we conduct the scan. Then for each policies we find out whether the setting was safe or unsafe. Now all the unsafe checks are finally converted to findings. So when I see the system, I can see there are two non-compliance and one is non-determined status. So I would just say prepare the audit. This is a place where I can do a bit of adjustment. So for example, this particular check is non-determined, session time limit settings, and the observation is that the system was not able to read the registry data. In such an eventuality, you can actually manually override the compliance. You can write your own observation, you can select the compliance, you can give a document as an evidence document for the compliance, and you can upload it over here. So this is the audit preparation phase, and this is how sometimes the manual and automated has to be mixed and matched to arrive at the complete compliance. Now once you have adjusted your compliances, you can finally finish the audit. Once you finish the audit, your non-compliances are converted to findings. So if you now go inside and see show findings, there were 3 policies which has been ran, out of which 2 were non-compliance and they are then been converted to findings. The next step is mitigation. So we have came to this 5 steps. The 5th step is remediation. Remediation is nothing but what needs to be done. Now RISC-free SCM policies are equipped with solutions and remediations, and it has an inbuilt ticketing system as well. So these are the findings which have been generated, and I can just simply click on remediate or mitigate. When I click on remediate, the solution of fixing the issue is already been copied, and I can select a responsible person who will actually do the remediation. I can set a start date and target date, and I can just say save. The person who is supposed to remediate, he will get an email, and once he logs into the system, if I click on my home page, because I've just assigned it to myself just to showcase how does it works, you know, it shows over here as an alert, and these are your actionable items, wherein it tells that a particular action item has been assigned in my name, and I can go inside and I can see what all remediation steps I have to follow. I will do the steps on the target system, and I will change the status and the percentage, and I can also optionally upload some evidences to mitigate the system or mitigate the finding. But this is what is all remediation is all about. Now once you have remediated, you can rescan the assets and you can find out whether they are properly been remediated or not. Now in such an eventuality, when you rescan the asset, you can go to your target devices and you can open your target systems. Let us say I'm just opening this one, and I can see a trend report. This is called as audit trend report. As you can see in this audit trend report, it matches the previous audit and the current audit scenario, and it tells what was non-compliances last time, which has been converted to compliance this time, or the vice versa. And this trend report is helpful for us to understand that whether a particular remediation has been conducted or not. So this is what is the overall workflow for by using the tool, how you can automate the configuration audits and remediations. Uh, there are some handy features which are there in the tool and which are helpful for us to track down. For example, we have a policy dashboard. Now as we have seen that from assets we can come to various remediations and audit findings. We can also do the vice versa. We can select a particular policy profile and we can drill down from the compliances or from the failures to the assets. So as you can see, this particular dashboard is clearly indicating that what all policies are compliant and how much percentage or how much times they have been complied. So you can navigate through various policies and you can see that how much was their compliance status. You can click on any of the dashboard item and you can see that in which assets they have been complied and in which assets they have been non-compliant. So you can drill down from the policies to the assets to find out where exactly the failure has happened, and you can prioritize the remediations on the basis of that. We also have a compliance tracker. The compliance tracker helps to understand or map the non-compliances against a particular compliance guideline like PCI DSS. You can observe that the distribution of findings as per the non-compliances, and this is how the tool operates. This is all what we have, and thanks for attending the webinar. This is mostly what we wanted to discuss. So I'm just reiterating, just to close the webinar soon, that what we have discussed is the key issues which has happened in past, role of the SCM in prevention of those issues, how you can automate these security configuration aspects using a tool like Risk2SCM, and how you can continuously monitor by looking at the trends. Now, this is with which we will sign off for the webinar. There is a small audience poll questionnaire which we will put up. I request all of the attendees to just quickly go through the questionnaire and give us their feedback so that we can understand your posture or your security posture, and if possible take it forward. So I guess you should be getting a audience poll questions on your screens. I just would like all of you to quickly okay, so I guess everyone should now be seeing the audience poll. Kindly take your 2 minutes to fill up the questionnaire, and so that we can understand about the webinar and about the security configuration management as a practice, how much it has been followed, and are you interested further, and things like that. Post the survey, we will have a quick question and answer session in which you can post any question. I'm here to answer all the questions if you have any. Okay, so I think survey has been completed. Thanks for participating in the survey. Uh, Now it's the time for question and answers. Is there any questions from the audience? You can just type it and I would be answering the questions. Thanks for participating in the survey and thanks for attending the webinar. If anyone has a question, you can just type it on the chat window. I would be glad to answer the questions. It can be anything, technical, functional, whatever comes to your mind. We would be glad to hear it out and answer and discuss it. Okay, so if anyone has any questions, you can just post it in the chat window. We'll just wait for a minute or so in case anyone has any questions. Okay, so if there are no questions, then it's time to wrap up. Thanks again for attending the webinar. I hope it was useful and there were certain key takeaways which you must have taken up with you. This is Amarnath signing off for Palladium Networks and hope to see you soon in some other webinars. Thank you and have a nice day.